Okay. The light is green. We're good. All right. Welcome to stream 16, episode 16. Um, Still don't know what to call these, but tonight we're going to be doing another R-115SW from Klipsch. These are common nuisance amplifiers, and you've seen me do a few in my other videos, and you're going to watch me do this one tonight. It appears to be a common issue, overheating, capacitor failure. So we're going to get into it and see what happens. I'm also trying something new with my microphone. Um, I've listened to some of my videos and there's a really annoying hum, so one of the things that I'm doing is trying a USB isolator for my headset, and so far it seems to be pretty good. One thing I need to do is turn off the feedback because I can hear myself, and that's no good. Alright, much better. Yeah, I could hear some buzzing and hum, and the audio quality wasn't that good, so I'm trying this isolator, and it seems to be better. It's not perfect. Um, it doesn't have a ground, so the ground on this is technically floating, so it still will pick up some noise depending on what I'm doing, but it appears to be a lot cleaner audio. So, like if I grab my little light over here, this is a non-grounded light. You can probably hear a hum start, and I can see it on my audio level. And if I get the light closer, it picks up the line noise. So it's not perfect, but as long as I'm using grounded tools and things, like if I grab my soldering iron, no noticeable hum. So it all depends on what I'm around. It still might pick up a little noise, but hopefully the audio quality will be a little bit better for everybody. We'll see what happens, but let's get into this. So here we go. Fix the camera a little bit. So just unboxed this, came in today. I'm planning on getting a bunch of amps shipped out tomorrow, so I want to try and knock this out tonight. And I did take a nap after work today, which is kind of uncommon for me, but I just had a long week and I was really tired, so maybe I can stay up and work on a few other things. I had some capacitors in, some big boys, fresh from DigiKey. These were on back order forever because of the component shortage due to COVID, so hopefully I can get those installed tonight and finish up another amp for somebody else. But let's get into it. I can see that this cap is bulged. This is that 330, and the resistor is just flaked and nasty, so this one clearly got hot, and it's probably going to be common failure. So let's get started and get this thing working. I'm going to try and pop the glue off without heating it first. Sometimes you can get lucky, sometimes you don't. Today we're going to get lucky. This red stuff, I don't know what it is, but it generally melts pretty good if you have problems with it. The black stuff is a little more difficult. This one looks... they tried to glue the connector in, but they totally missed the connector. So, awesome quality control there. Actually, the black stuff's coming off pretty easy, too, without any heat, so... maybe tonight's going to be a good repair night. We shall see. I have my parts list. I will get that on there so everybody can kind of see it. You can pause the video. It should be focused enough to read it. That's what I'm going to be working off of. All these amp boards appear to be the same, no matter which version of this sub you have. These guys are bent a little bit. So all the caps should be the same. Some of the layouts are a little bit different. Some of you guys might have that big ceramic white resistor here. I have had really good success with mounting these on the bottom. So I'm going to continue doing that. These are 820 ohm 5 watts, and I'm going to put it on the bottom of the board. I don't own one of these subs, so I didn't know how they actually sat inside the wooden enclosure, and I didn't want to put it close to anything where it might burn or catch on fire, but apparently there's plenty of room, and there's no issue, so we will do that. Let's get into it. This one is smothered in glue, so we're going to have some work cut out for us. All that glue's got to get removed, unfortunately. We might be here a while on this one. But if you're a night owl like me and you have nothing better to do than hang out and watch a repair video, hey, let's get into it. Heating up my solder sucker, so that's going to take a minute. This one isn't, one of the worst ones. It might be one of the worst ones I've seen with glue, but it's not one of the worst that I've seen with the caps and resistor failing. Nothing appears to be too far gone yet. Nothing burnt on the bottom. Should be alright. Should just be a routine repair. I have not tried the solder sucker with the microphone yet, so let's see. Yeah, it looks like I get a little bit of hum when I touch that. Oh well, can't win them all. I'll have to continue investigating different audio sources to try and alleviate that. Probably buying a high quality preamp would solve it, but I'm kind of out of space on my shelf with my equipment up there, so we'll have to figure something out. I put the wrong tip in, so you know what, we're just going to start snipping. And I'll check the values against my list. I haven't found a difference yet, but we'll just check 2 or 3 and make sure nothing's terribly different. These have bent leads on all the caps, so desoldering them is going to be a pain unless you cut them off first. There's really no way around it. This is one of the first ones I've seen where these 2 caps on this board have not been totally covered in this like rubberized stuff, so that's good. I usually don't replace those though, they're almost never bad. Actually, I've never seen any of those go bad, and you can't really get to them, so I did one repair where I removed all this stuff because I had to replace the audio jacks on it. Never do it again. It's not worth it. If anything on this part of the amp is broken, throw it out. Find another broken amp on eBay and rebuild that one. Alright. The silk screen on these is microscopically small, so I gotta get out a magnifying glass to read it. C48. C48 is 125, so we're good there. This one should be the same. 125. You know what's bad if I start memorizing all these. This should be 16 volt 330. Yep. Actually, we can take out the resistor. I'm going to take the transistor out too because there's a bunch of glue in that area. Everything else looks pretty good. The glue around the main filter caps is a little crunchy. And there might be some damage right in here. I know that's hard to see, but I did get a another camera like my overhead that I can pan and zoom, and I plan on mounting it on my sidewall, so hopefully I can get some better working shots, or at least do picture in picture. I'm waiting for a cable to come in. I'm cheap, so I refuse to buy like a brand new expensive camera. I just got a parts one off of eBay that I'll make work. Sometimes you got to add a little bit of lead solder to help liquefy this lead-free crap. But should be a routine repair. Alright, you can see this guy's a little toasty. This is the root of all your evil on these amps, is this resistor right here. And I'm not going to zoom in, but you can clearly see that it is nice and crunchy and crispy. Probably still holds its value. Just for the heck of it, I'll measure it. I believe these are wire wound, so it's drifted a little bit. It's showing 978, so yeah, this guy got a little hot. I believe these are 3 watts. I used to replace them with 3 watts, now I do 5. 5 is better. And I space them off the board and I give them a little lead link so they can kind of cool off a little bit. And there is some corrosion on the board. Hopefully that's, yeah, it looks like it's just charred glue, so we should be alright. Let's continue. I do have the chat window open, so if any of you have any questions or get bored, feel free. I'll try and pay attention to it. I can't promise I will, but it is open. Typically the transistor is reusable. I'm just taking it out just because I want to get better access into all the parts. A good pair of nippers is your friend. I still have not found like a set of needle nose ones that extends way out. That's what I really need to get in here and make this job easier on myself. But for now I kind of just push them out of the way as best I can and try to be careful not to damage anything else while I'm snipping them out. This would probably be an hour less of work if the leads weren't bent on these. So I could just unsolder them all and pull them out all as one like big group. These are probably done on a wave solder line though, so they mount everything on and run the whole board through, so they don't want anything to fall out. And I'm guessing they probably glue them before they solder them in there. That would be my guess. Maybe not. But just be careful not to damage any of the surface mount stuff. And get all the caps out. This one over here is going to be an issue. Cheap caps and heat are not a good combination. Good caps and heat are not the best combination, but they seem to last a little bit longer. Cheap ones and heat, forget about it. The majority of the time on this is going to be spent pulling leads and clearing glue. If you've watched any of the previous videos, you'll see that you know, getting all that stuff off there is one of the critical parts of having a successful repair. I can see on here these have the Kituo caps, or Kyudo, or whatever the heck they are. These guys are really hard to get to down in here. I might just leave these and pull the leads on them. Alright. We gotta get the big boys out. I have to change my tip for that. Hopefully this guy's cooled down enough. I didn't check my inventory. I hope I have these in stock. Seems like no matter what I do, I'm forever running out of a cap. You can see the glue while we're waiting for that to heat back up. It's really nice and burned all the way around here. So all of that has become conductive, and anything that's underneath here is getting shorted out. So that has to go. There really is no easy way to do a patch repair on this. You almost have to do it, you know, a full recap and clean if you're going to even get into it. I mean, you might be able to just replace the parts that are damaged, and it might work for a little while, but all of this brown glue is eventually just going to destroy the amp. And once you get into surface mount, you know, you can't really get to this board, so if you have to replace surface components on this, you're going to have a really hard time doing it. I would not recommend that route. I got plenty of coffee tonight too, so it's going to be a good night. I think my solder sucker is clogged. I'm not getting anything out of here. Sounds a little better. It could be also, sometimes you got to break them off the board so you can get a little air underneath them. That definitely helped. This guy didn't move, so I'm probably going to have an issue with him. Garbage caps and garbage glue. I wish I knew who made this amp. Usually, well, Klipsch amps used to be made by Bash, which was bought out by Sonavox. There's a sharp edge on here. We're gonna have to fix that. Apparently, this guy had problems getting his board out, so he was popping a screwdriver in there, and there's like a razor sharp burr on here. I'm gonna cut it off. Sorry, buddy. Put a little black Sharpie on that, and that'll hide that. But I don't want to get a hole in my finger when I'm using, or when I'm trying to move your amp. Alright, there is some gnarliness there. Nice and gross. Just for the heck of it, this one looks worse than the other two. I want to see how far off it was. Usually the big caps don't go bad, but sometimes they do. So I don't know. Let's see how far out it is. I'm curious. Actually, no, it's just still good. 98 out of 1,000 is pretty good. So I'm surprised. I would have thought that those would have sustained a little more damage than they did. This black stuff seems to be coming off dry, so I'm going to try and pick as much of it off as I can before blasting this thing with heat. It appears that the heat from the amp like kind of crystallized it a little bit or something. I don't know. It's coming off in chunks. It's making a mess though. No clue where that just shot off to. Hopefully not in my coffee. I don't want to be drinking poisonous Chinese glue. Alright. Caps are off. Now, got this little guy. So I found that there's a couple different revisions of this. Let me zoom in on this. I don't know if I've covered this before or not, but we're going to cover it again if I did or didn't. Some of these amps have a ceramic cap down here. Right there. And then they just put an electrolytic over the top of it and across it. Some of them just have the cap in there, and some of them have nothing. So there's been, a couple of modifications that have been done to this. Different revisions. They put the version on here. This says version 1. I haven't tracked it. If it has the rework on there, I just put the rework back on there. That's kind of how I do it. But there are a few different versions of that. I'll save that guy. Actually, no, I'm going to pull him out now. And the reason is because there's glue behind it. Desolder this one if you can so you don't mess up the surface. Oh. I know it's kind of hard to get like way back in there. You can kind of see that it's just tacked right onto the side of that cap, so I'm just going to heat it up, hopefully. Again, this is lead-free solder, so it is not friendly to work with. Sometimes you got to dope up the joints a little bit. And we'll clean that up before I replace it, but I just want it out of there so I can, all this glue that's here, back behind here, all over here, and all this, and all the glue has to come out. Everywhere you see glue, it's got to come out. That is the main pain in the ass with working on these, is you got to get all the glue out. Whoops. That's another project. We'll save that for later in the week. I'm rewinding some really small brushless motors that I burned up on one of my quads. It's actually not that hard to do. I was kind of surprised. I thought it was going to be a royal pain, and it's a lot easier than I thought. Gotta make sure I unmute every time I drink my coffee. I don't want to be talking and have nobody hear what I'm saying. Alright, heat is your friend now, so I'm going to get out the heat gun, and I'm just going to work this glue. And there's really this is why I need that camera on the side so you guys can kind of see this. I'll try and prop it up. That helps a little bit, but I'm just going to heat. Sorry about my hose there. I can't really do anything about that. Just going to get the glue warmed up, 120°C, until it softens. I wouldn't go much hotter than I'm going. The reason being, you don't want to weaken any of the solder joints. All you want to do is just get the glue so it's kind of like bubblegum consistency, and then just start working it off. And it comes off okay if it's in good shape. If it's kind of burnt and crusty, you're going to have some issues with it. But once it softens up a little bit, it comes off pretty good. I like to stick my tweezers in there and just kind of twist them around while applying heat. And you'll see it just comes off in a glob. And then you burn your fingers when you're trying to get it off your tweezers. This one's gonna fight me, of course. So yeah, sometimes that happens. Tweezers get glued. Well, yeah, I start on this side of the board and I just work my way down. Get it off of the op amps, get it off of the switch lines, and make sure you're being careful. You don't want to, if you're using a dental pick or another pointy sharp tool, you do not want to pop any components off the board. So a lot of these surface mount things are kind of tiny. You just want to get the glue warm enough to where you can peel it and get it out of the way. And I mean, if you have to leave a little bit in there, leave a little bit in there. It's better to risk having the glue cause a problem than actually damaging your board because you're trying to be a little too thorough. But like I said, the tweezers and the twist seem to work pretty good for those hard to reach areas. Remember, 120C is hot too. So if you have sensitive fingers, keep that in mind. Try not to heat your film caps up too much. Film caps do not like heat at all. Feels like my AC is turned off. It is hot down here. I put a Google Nest thermostat in my house, and it wants me to be energy conscious. So when nobody's walking around, it like changes the temperatures on me. Alright, I gotta get rid of the kickstand. Or at least lay it down. It's making it too hard to work. Sorry about that. But you guys get the point. Remove the glue. Now, glue that's not touching the board, I don't touch. If it is touching the board, it generally has to come out. And they really smothered in this. In between this op amp and this film cap, there's a couple of tiny parts in there, so again, be careful. Don't tear your resistors off the board. I don't understand, you know, with the caps bent like they are. I don't really understand why they went this crazy with the glue, or why they even use glue at all. It's really not needed. Bear with me for a second. I'm roasting. I gotta turn the air on. Technology, gotta love it. It says we're at 77. I don't believe it. Take it down 1 degree. Alright, so glue on this part of the board is clear. We got the little bit that was back here. We're going to go over towards the pot now. There's some back in there. Remember, we got to get to this mess. Let's continue. One of the things that is kind of nice is this glue does have like an affinity for itself, so once it gets, you know, up to temperature, it does tend to, you know, help peel off. Which is kind of nice. It's actually going better than expected, which is weird, and it's kind of scaring me because that makes me think that something bad's going to happen. Alright, now onto the crusty stuff. There's really no easy way to get the crusty stuff off. You just have to pick it out carefully. It generally does not come out nice. I still give it heat. Heat does help, but not nearly as much as if the glue is nice. You gotta kind of be careful. Just work around the components and the component legs. Use your pick. I know it's hard to see, but I'm doing right around these SOT23 transistors down in here. And just kind of digging at them and doing the best I can to get it out. Like I said, I'll have a side shot looking in on this direction, hopefully in a few days. So when I get to number 4 or 5 on these, we should have a little bit better of a view. But for now, you can stare at my head while I pick this glue out. Now this is, you know, exceptionally bad on the burnt glue, so I am going to hit this with a wire brush. I want to make sure I get, you know, as much of the residue off as I can. It was, you know, charred pretty bad. It was actually getting, you know, close to damaging the board because a lot of the solder mask is missing. So I'll take a brass wire brush and just kind of go over all these parts. It will take the labeling off of a lot of them, but it doesn't really do any damage. But if there is a problem and I need to test it, it'll also make it a lot easier to test, because everything will be nice and clean. I have seen cases where this inductor's been glued down and the glue's gotten a little crusty underneath it. I've taken a few of them off, but one thing that I've noticed is there's really no way for this to short out underneath it, so you can generally just leave that alone. If it's glued and it's really bad, you know, use your discretion whether or not you think it needs to be removed, but generally I don't think you need to remove it. I'm going to be doing a lot of these too. I have 3 of these coming in just this week alone. I know on my waiting list there's a lot of people that need these amps repaired. And I guess I must be the only one doing it. I'm actually hoping that, you know, some people watch these videos and other people start doing it, because I'm going to get tired of working on these eventually, because it's not really challenging anymore. It's just the same thing. It's remove the caps, remove the glue, recap, and it works. Which, I mean, it's alright, but I need something that's a little more of a challenge to keep me engaged, otherwise I get bored. Try not to breathe while you're doing this too, because this glue does have some nasty smell to it. I don't know what the hell it's made out of, but heating it up probably isn't that good for you. Again, be careful around the film caps. Not too much heat, just enough to remove the glue. They should be rated for 150C. Or 105C, sorry. So if we're hitting them with 120, they're not going to be able to take that much heat for too long. But we want to get it out of there because it's especially crispy in between the inductor and this. So once you get them a little warm, you can kind of scrape. Just make sure it's off the board. That's the most important part. And you can get a little aggressive with it. Just you know, make sure you're not scratching traces off the board. Like I said, this one is just absolutely smothered in glue. If it's extremely bad in here and you think you're gonna have problems, pull these caps out. These ones don't look too bad, so I'm just gonna try and work around everything. Alright, we're almost almost there. Most of this problem is caused by not turning off your amp. Leaving your amp unplugged or plugged in. So if you have one of these and it's not dead yet, you better go and unplug it. If you're in bed right now and you're watching this video, get up and go unplug your amp. I'll fix it for you, but I don't really want to. Alright, a little bit of black glue by our op amp over here. The op amps generally get kind of warm. Warm enough to make the glue nasty, so make sure you give those a good clean. Actually, I'm sorry, this isn't an op amp over here. This is the switching controller for the power supply, but around the op amps too, they get it gets crusty. Alright, now we have behind and down on the bottom. Try not to burn yourself. I've burned myself like 6 times already. It hurts. Down here in this little bottom area, the twist method seems to be the best. It continuously pulls the glue off. And if there's a hard to reach spot, it kind of tends to get it all out of there. I'd like to find the guy that, the engineer that said, oh yeah, we got to glue all these parts in, and have a cup of coffee with him. It wouldn't be a very friendly conversation, though. Probably be like, what the hell were you thinking, and why? The most surprising thing is Klipsch is known that this specific type of glue has caused problems for years and years and years. Like, it started with their Synergy series, probably even before that. So I don't understand why that, anybody in quality control would allow this to happen again. I mean, it's literally plastered all over the internet that this glue is bad. Somebody, has to have seen these. I'm actually going to have to pull the inductor out. I can't get all that glue out from behind there. Not easily. I knew this was going to be a challenge and a pain. I'm going to pull these resistors out too. Might as well just take everything out. Make sure I'm doing the right parts there. This is on a massive ground plane, so it's going to be kind of hard to heat it up. I generally don't like doing this, but I don't really have a choice. It should make it a little. It'll make it easier to get to that other cap too. So I'll just pull these off, clean them out, and put them in last. All right, just let's take the inductor off. Inductor's held in by 2 pegs. I think my solder sucker's either that, or my sucker's clogged, or my filter has reached end of life. Probably a little bit of both. Or the other thing is this is glued so well down to the bottom that yeah, my solder sucker filter's clogged up. I will have to replace that. Okay, I think I have an air leak. Let's see what's going on there. Time to replace the filter. Hopefully I have a clean one. Give me a minute, please. Sorry about the delay, but sometimes you gotta do some maintenance. That thing is heavily used. And I do have some new ones, so we're in good shape. And I keep a spare heater too. Never know when you're gonna need that stuff. Be in the middle of a job and have your heater go out. That's a bad day. Alright. That sounds a little better. I do recycle those cartridges, so night and day difference. I clean those tubes out and then I pack them with a little bit of Pink Panther fiberglass, and they're like brand new. Works pretty well. Alright. Pop this inductor off. It's going to be screaming hot from heating it up. And you can see how crusty it is back there. That's the rest of the glue that needs to come out. So I will get on that. I know you can't see that. I apologize, but I got to get this out. That was a free coffee, by the way. I am not a believer in paying for coffee. So all you Starbucks nerds out there, we're not friends. If you pay more than 50 cents for a cup of coffee, you're crazy. This other resistor is kind of nasty, but if we just clean off the board area around it, I think we'll be okay. Whoever glued this was definitely trying to get a promotion or something, though. They use a lot of glue. Overachiever. Except what they don't realize is they overachieved at ruining the amp. Alright, a little bit more to go. There are a couple of surface mount parts back inside here, so be careful. Try not to get it too hot. I have damaged one of those capacitors by getting them too hot. Yeah, I gotta take the other resistor out. Alright. Know this is probably going to cause some hum, but I need a little bit of light down in here. I think one of the problems is they put so much around that resistor, and those resistors do get warm. I think that's what led to a lot of this glue getting extra gnarly. This definitely won't be one of my prettiest repairs. But I guarantee you we'll get it working. That counts. Who cares what it looks like on the inside? do see something that looks like an issue with this capacitor here. I'm going to have to investigate that. The red one does look like it has a crack in it. I do not believe that was caused by me. I'm not sure. I might have a couple of those. Well, I can steal one out of a donor amp if I have to. Either way, this amp's getting done tonight. I'm not going to postpone it while I wait for parts. This diode is just killing me. Completely covered from head to toe. And underneath too, dang. Alright, almost there. Still got glue on the diode. This might be the worst one I've done. I don't know. I'm gonna have to do a little evaluation on this guy. This is absolutely just terrible with the glue. A little bit more in the back here. One of these resistors in the one pot. Just a tiny little bit more. Just get it off those components. Alright, I think that is it for the glue. I gotta grab some paper towels. I will be back in a second. Here, let's give everybody a little look at the nice clean board. That's what it should look like when you're done. I guess I'm, oh, wrong way. Zoom in there, camera. Well, I guess that's as far as it zooms in, but that's what the board should look like. This is what the glue did look like. That's a nice clean board. Now there's still some junk in here, a little corrosion, and this cap. I don't know if the camera's probably not going to pick it up, but yeah, maybe you can see it right there. It looks like there's a little crack in there. So I need to investigate what's going on with that. Actually, I'm just going to do that right now. I think it was just dirty glue. Yeah, okay. So no crack. That was just some crusty glue. We're good. I gotta go grab some paper towels. I will be right back. Alright, let's get back to it. So, I'm gonna give it a once over. Make sure that there's no crusty stuff on it. Try and clean all the little flakes and remnants left over in there. I will blow it out. I'm gonna have to mute the microphone again for that, and hopefully actually I think I have to leave again. I gotta go get a wire brush. I used my wire brush for something else. I gotta go grab a brass brush too. My brass brush was upstairs, so sorry about that. I will be back again. Alright, hopefully no more disturbances, but really fine wire brass brush. I get these on Amazon. They're pretty cheap, but they're actually really high quality brushes. I'm surprised. Um, the ones that you get at like the local hardware stores tend to not have as fine of bristles and not as densely packed as these, so I like these. I don't know who makes them. Just cheap brushes, but they work really well. And I'm doing this over my garbage can, but I'm just, you can probably hear it. Just where the corrosion was on the top of the board. I had to blow it off too, so I didn't want to fry your eardrums. I know the microphone is a little louder than it was before, so I'm trying to keep that in mind. But what I just brushed this area right in here, just because there was like some residue and some nasty stuff on it. I wanted to make sure that it was cleaned, and it looks pretty good. Oh, hi, dog. My dog came to say hello. I don't think my camera goes back far enough. Probably won't be able to see the dog. Let's see. Let's see if we can say hi to the dog. Oops, wrong way. There's the dog. Say hi, Juno. Nope. She just wants to chill. She's got her little dog bed back there so she can hang out while I'm working. Best dog in the world right there. Alright, back to work. So we have the glue removed. I've checked the board. It looks good. There's no more residue on there. Actually, there is a little bit of residue. Actually, we lost a resistor. Ah. So, if you look right here, let's zoom in again. We sustained some damage. And again, it's going to be kind of hard to see that zoomed in, but right here on these two pads, there's supposed to be a resistor. And I don't remember what the value is. Uh, 1001, so that's what, 1K? So the cap leaked, the 330, or no, I'm sorry, this cap, C80 leaked from getting too hot, and it corroded those pads, and we lost a resistor. So we are going to have to try and get that going again. I don't even know if the pads are there. The pads might be completely gone. If the pads are gone, I will try and rework it. I'm using my fiber scratch pen to try and see if I can get the copper back. These little Euro tool, I know it's kind of washed out in the light, but Euro tool pens are awesome. Again, another Amazon find, but definitely a really good tool. You need to have one of these if you're going to do any surface mount work. And I'm just going over this. It's going to remove some solder mask, but that's okay. What I'm trying to do is just get the pad cleaned off and exposed. Cleaned off and exposed enough so I can put that part back on there. So alright, so we do have something a little bit different with this guy. I apologize again for the humming. I'm just looking at this pad, and it looks like there are some buried through holes on there. I'm going to double check on a spare board that I have, which I happen to have right next to me, just to make sure that something actually does go there. I'm pretty sure that that gets a resistor, but maybe not. This is, what is this? This is a R-110. So I actually do notice a difference on here. The caps are a little different. These are only 63 volt caps. These are 80 volts on the other one, so there are some differences on a 110. As far as everything else, I think they're all the same. Again, this one's smothered in glue too. So yeah, there is a resistor there. I will check the value, and I'm going to have to check and make sure that the traces aren't destroyed either. And it is a 1001, and it looks like it goes right to the two vias that are right next to it. So Alright, that's the thing that sucks about not having schematics. I'm going to work a little bit with this magnifying glass to clean it up, and then I will show everybody what it looks like. And I apologize for touching this light and causing that hum. There's definitely some damage on the pads. You can use an X-Acto knife to scrape them clean just to get some of the nastiness off of them. But I would definitely polish them with the Euro tool after you get the corrosion off. The fiber pen really isn't gonna eat through the copper, but it will clean it up. I don't know where the other end of this goes, so I'm gonna have to try and ohm it out. Now the electrolyte did eat through the pads. The via still looks to be intact, going through the board or into one of the internal layers. I'm hoping that it still makes a connection. If not, I'm going to have to relocate this resistor. And if it's too bad and I can't fix it, what I'm going to do is just replace the amp. I have a shelf full of these things, and I'll just grab one of those and start over. So the through hole is right next to the cap. So it goes large resistor, then 2 vias, then cap. So let's see, we have a large resistor, then it looks like one goes to this big plate here and one goes to the other side of the resistor maybe. So let me prop this guy up here. We need a better angle. We need a steep angle. I need to make a kickstand with a 45 degree. What can I lean this on temporarily? Bear with me while I make a little stand so I can show everybody what I'm doing. Yeah, I'm just going to have to hold it. I don't have an easy way to prop this up. What we're looking for is this resistor that went on this pad, these pads here. There's one over here, and then there's one that goes right here and here. And I am looking to see where this connected and if these pads are still good. So I'm going to check for continuity. I believe that this one here connects to this spot where this resistor went, this through hole here. So I'm going to check and see if this pad here and that have continuity, and then this one should go to the ground plane. And the big ground plane, I think, is common with the large pad that the cap went to. So we're going to check for continuity. I'm going to think of a way to make a better kickstand, but right now we'll just listen for beeps. That'll tell me if the pad still has connection. And what it was connected to. So I think, so that does not go to that. This pad here, so one pad does connect to ground. The other pad is connected to the via. Okay, and that connects to the far side, the far resistor. Now the via is connected. Let's lean this back a little bit so you guys can see. This spot of the resistor comes to this little via on the top. And I know it's extremely hard to see, but I can't zoom in anymore, I don't think. Let's try. Yeah, I'm all the way zoomed in. But if I go to the pad is no good. If I go to the through hole does connect. So the pad is no longer connected to that. Now you can rework that. It's really difficult to do. Instead of doing that, I believe that it's just paralleled with this other resistor. So we're going to check that. So if I go from this spot here to the back of this resistor, we have continuity. And if I go to the front one, we got to find something else that it connects to. And I thought these were in parallel, I guess. Wait, they are. So I was checking the pad. If I go to the little through hole, the front of this resistor is connected to that through hole, which is also connected to the other side of the large resistor. So let me try something here real quick. Let's live life a little dangerously. I bought a little bullet cam, and I was playing around with it, and it actually works pretty good, but it doesn't work for hanging on the wall. I tried it. I was very unhappy with the results. You guys would be very unhappy with the results. But for something like this, where I'm trying to explain a really detailed circuit, everybody might benefit from this. So let's try it. We have nothing to lose, except for me trying to find a USB port on my computer. I might lose at that. This is a I've seen this twice now, so I feel like it's worth taking a few extra minutes to really go into detail and explain how to resolve this problem. Just bear with me while I get plugged in, and I should be able to zoom in with the little bullet cam here. Then it has a built-in light, which is kind of cool too. Microscope. Bear with me while I try and get this thing dialed in here. I don't know if I will be able to get it or not. Let's see. Microscope. Let's add a video source and see what happens. I'm not that good with Broadcast Studio yet, so bear with me. Oh, look at that. We have something. Alright. That's not what I wanted to do. Well, apparently the aspect ratio on this is locked, but anyways, we can get in here and look at this. So, as soon as I find which way's up. Let's find a point of reference and get in here. And it's going to be a little shaky for the time being until I find my direction. So that's upside down. That's why this is another reason why I don't want to use the borescope, because I can't tell which way's up. Alright, I should mark it. So here's the damage that we're looking at. And this thing doesn't have autofocus. That's another reason why I don't want to use it. So this resistor here, and let me turn the light down. The light's kind of washing it out. And no light is better. I'll give it a little bit of light. It's reflecting really bad off the board. Alright, no light. We'll use ambient light. So here's what happened. This cap right here, which is C I can't read, started leaking. The electrolyte went out, and it went, around this, probably underneath the glue. And there's a via right there. And I don't know if I can get that to show or not. Even lit up, it's going to be hard to show. I'd probably need a microscope. But I can hit it with my meter. But there's a via right here, right where my tweezers are pointed. And that via connects to this through hole, which is for the high wattage resistor. Now, this resistor also connects to that. So here and here are the same, and in the back here and here are the same. So since this resistor is damaged and the through hole is no longer functioning properly, what I'm going to do is I'm just going to take the other resistor, I'm going to put it right on top of this one and just stack them. So if you have a board that's screwed up and you can't fix this, or you don't want to fix this, you can just stack up two of the resistors, and it's a workaround fix. If you really wanted to, you could dig out this through hole, place a new piece of trace over and rebuild it that way, but it's just not worth it. It's not worth wasting the time. You have a trace going underneath that's kind of delicate, and actually I'm going to make sure that that's not damaged either going to this capacitor. But since this guy's gone and this pad here is damaged, I'm just going to stack these two resistors up. So it's a 1001, I believe that's a 1K. Stack them, and that should be the same as these two, and there's some on the bottom of the board too, so you don't have to put it here. I'm just going to put it here because it was, the closest spot to that one. But that's a perfectly acceptable workaround repair for this. The other option would be just trashing the board. I've done a repair similar to this before. I put it on the bottom of the board. Amplifier worked just fine. Had no problem. So that's what I'm going to do with this one. And I wish this thing would autofocus, but you can see back here that this pad is chemically etched and eaten away. So it's damaged there, and it's damaged right here because it's not making a connection with the rest of the board. So reusing those pads are out of the question. We're just going to ignore those for now, and we'll stack those resistors up. So that's how you do that. Little boroscope did come in handy. I'm going to have to keep this thing around. I wish it had autofocus though. It sucks that it doesn't have autofocus. But we have our first interesting and different repair. I can see it great under the magnifying glass where it's supposed to make connection with that pad. Now, another thing you could do if you wanted to is you could drill that through hole out and put a new via in there. It's a lot more work than needs to be done. I don't see a reason to do it. And you really, if you wanted to, you could put the resistor on this side of the board. So, a couple different ways to go about doing it. I'll show you where to put it on the bottom of the board. So, the one pad makes connection with the positive of the cap. The other pad is supposed to make connection with the front of the resistor. So the front of the resistor is here, and here's the pad for the cap. So if you wanted to, you could scrape off, maybe we'll do it that way just to just show how it's done. Scrape off a little bit of the solder mask here and just put the resistor between this weird shaped pad and the ground plane here. So you're making a connection between the two, and you're just taking it from the top side of the board and putting it onto the bottom. Perfectly acceptable way to do that. I'm going to stack it up on the top because I'm putting the higher wattage resistor on the bottom. And I think these other two are, I'm just going to check. Yeah, so these other three resistors here, which is again going to be hard to see. 1, 2, 3 are also in parallel with those other ones. So there's 5 of those in parallel along with the 820. And there might be a couple more. I'd have to further investigate. But any of the 1001 resistors in this area are going to be parallel together. So you can flip them, you can stack them, you can put them on the bottom of the board. You can really do whatever you want as long as you get them in there and get it connected. I have to make sure I have one of those. I'm pretty sure I do. That's pretty common size. All right, let's zoom out and start the recap. I'm going to have to edit the title of this so anybody that's browsing can see that this repair is a little different than the rest. I'm going to change tips in my solder sucker. Unfortunately, I did not turn it off, so it's going to be scorching hot. Use the water trick. Thermodynamics, awesome stuff. I'm going to go with one of my smaller tips just because these tend to clean out the through holes just a little bit better than the other tip does. All right. letting that heat back up, and we will get moving with this repair. While it heats up, let's see if I got this resistor here. Resistor's through hole. You could put a through hole on there if you really wanted to. Doesn't really matter as long as the values are the same. Let's see, surface mount. 10 ohm, 100 ohm. I can't ever remember the codes on these. Yeah, it's a 1K. So I got 36K. I have 100 ohm, 10 ohm. I organize all my parts in these little baggies, and then I can fit a ton of them in here. Alright, 1K, 1%. That'll work. 0805, it's the right size, so I do have them. So when it comes time, we will pop that resistor in there. Maybe we'll put it on the bottom. I don't know. We'll see. It doesn't really matter, but it might be a little better for cooling. So maybe we'll rework it and put it on the bottom, just to make it a little more interesting. All right, solder sucker is heated up. We're going to go with our somewhat magnetic tweezers and start clearing all of these leads that are in here. Much easier to do if you put a little leaded solder on here. I'm just going to try and be a little lazy tonight and not do that. Actually, it's not going to work because the pads that are connected to the ground plane have to be hit with some lead. You got to get a lot of heat in here to get these things loose. You can almost tell where all the caps are just by looking at which leads are bent. This is the one that we have not taken out yet. So this guy, I'm going to try and desolder and pull him out. It's a lot easier with the little tip. When they're covered with glue, it's never easy. Alright, we got one leg free. I need my tweezers. What did I do with my tweezers? There. If you move them while you're applying heat, you can get the legs hot enough to come free. And then use a pair of pliers or your nippers or something just to try and straighten them out enough to where you can actually get it out of the board. It doesn't always work that way, but sometimes it does. Try not to stab yourself either. These tweezers are fairly sharp, and they will do some damage. Alright, that is a film cap, film cap. Film cap. Where are all the electrolytics at? Got 3 of them right here. You would think I would have this memorized. I should just make a printout so I can look at it while I'm working from the bottom. Make it a little easier on myself. So where the legs are overlapped and folded over one another, you almost have to hit it with a little extra juice to break them free. Still haven't found a better way to do this though. It's quite unfortunate. I would say bent component leads are probably equally as hated as thermal paste to me. I totally despise thermal paste. Bent leads are like right up there with it. If you were a repair technician and you bend your leads, you should quit your job. Alright. Let's just give them all some juice. They seem to come out better. About halfway done with popping these out. You could probably get away with even leaving that resistor out, that little surface mount one. Since they're all in parallel, the change would really be insignificant. It's such a low value. I never measured the total resistance across all of that. I'll do that before we start popping parts back in, because I'm kind of curious to see what that is. Got this guy here. And seeing what the, if you did leave that out, seeing what the difference would be. I mean, I'm going to put it back in just because it was there. And it's supposed to be there, but I'm guessing the difference with leaving one of them out is going to be probably pretty minimal. I honestly might not even be able to measure it. It's probably in the sub-ohm category. My meter will not go down that low. These are the two that would not come out. I couldn't reach them. Again, doing the wiggling lead method and soldering it back in place. I gotta clean my tip here. That one actually came out quite nicely. 4.750. See if this guy, yeah, he's coming out too, good. 2 or 3 more and we can start rebuilding. There's one here. That's partnered up with something else. Actually, I think, yeah, there's 2 of them right next to one another. There's one leg. Careful when you're taking these off your tweezers too. They are still hot. You have to have it worked down to a fine science to not burn yourself. Alright, let's see, what else do we have here? We're all clear there. I found a little more glue that's got to go. We'll get that. 2 more caps. We have main trouble cap, 3 more caps. We have the 2 that are on the side of the resistor. I think my dog is snoring. I can hear her behind me. Either that or she's growling at something. Nope, she's having a puppy dream. Probably dreaming about chasing the Amazon guy. If reincarnation is a thing, I want to come back as a dog. A dog that has a good family. Kind of hard to beat that life. Good food, you get toys. People come and play with you. It's the ultimate life. It's like living like a millionaire. You have everything you want and everybody caters to you. Alright, I think this is our last cap. Oh, and those went all the way to the bottom of the box. How does that even happen? I dropped my tweezers into the graveyard and they went straight to the bottom. Alright, try again. Last cap. I think that's a sign that I need to clean up my area a little more. Totally just nuked my finger with something that hurt. Solder sucker is clogged. Gotta clean that out. Not totally clogged, but almost. Oh yeah, it's clogged pretty good actually. Alright. One more leg to go. I think that's it for resistors, or I'm sorry, for capacitors. I gotta clean out my solder sucker again. I need to get a new cleaning rod. The one that I have is just not the right size for this. That's why you see me using components to do it. Here we go. The leg of this resistor should get in there. Bear with me in case I have another one. I just want to make sure my tools are clean. My workbench might not be clean, but I want my tools to be clean. Without these, I cannot do my job. And component legs are not the best thing to clean with. Keep that in mind. Alright, let's see where we're at here. So all the capacitors appear to be cleared. We have a little bit of glue in one spot. I'm going to try and take care of that without using heat. It's probably not going to happen because this glue is just totally gnarly. Alright. Board looks good. I want to check that one trace that I was talking about earlier. You guys are probably not going to be able to see that. I'm even having trouble finding where it goes. It goes from... Looks like it goes from a resistor up to R1 troubled capacitor. I see something else I don't like in here. It looks like R26 is having some issues. I gotta measure R26. It's looking a little gnarly. And I'm gonna check that trace. I don't want to get this thing all put back together only to find that there was another issue with it. So we'll check the trace first. I want to find where it originates. Alright. It starts on a through hole. And it goes up to the transistor. So that trace is good. Now I want to check the value of this resistor that looks a little questionable. We'll check his buddy first, the one that's right next to it. $2.55K. That looks alright. Freaking bug crawling on my desk. Get out of here. Scaring the hell out of me. Seeing little things moving around. Goodbye, you're dead. Alright, I can't read the value on this. The value is totally gone. It looks like 472 on that, and I'm not reading 472, so I'm gonna have to take a in-circuit measurement on both of these on a different amp. In circuit, you're never going to get an accurate reading. This one's 300K and climbing. Let's reverse the polarity of our probes and check again. $2.5K climbing. 2.5K. So again, one of the unfortunate things is since I don't know what these values are, I got, you know, a donor amp. I got to get in here and try and just do a comparison between the two. So the resistors on this one look a lot cleaner. And again, I know this is hard to see, but it's actually going to fall over. I'm just checking the two resistors that are by this little SOT package that's right here. You know, one of them just looked a little weird to me, so I want to make sure that the in-circuit values are reading the same as this amp. So this is reading 2.9-ish K and climbing. And this one's also reading 2.89K. So those are a little bit lower values, but I also don't have any of the capacitors in place, and this has bad glue on the board. That could be throwing it off. Alright, this is reading 2.8K that way. $2.89K. So the actual values of those are 472 for both of them, which is 4.7K, right? Does that sound right? I don't know if I have any of those. We can look. I mean, that's a pretty common value. I have 47K. That's an 0603 though. This is an 0805. These are 4-band markings. The question is do I pull them out or do I think they're good? That is the question. Well, this one I can't read the markings on, but that's also where all the glue and electrolyte was. I'm going to check the connections and make sure that those are connected to the legs of that transistor. are good there. So I got 2.5, 2.7. I'm going to say these are good. And I believe that they are connected in parallel. We're going to check that out right now too. No, they're not in parallel. I can kind of get to these after I put this thing together. So I'm just going to give this a little shine up in here. And we're going to run with it. I will test everything and make sure that it behaves. I believe they're good. I'm not getting an open reading, and the numbers really aren't too far off from everything else. And I have a lot of stuff depopulated out of this board right now. If I have to, like if I have problems and the amp's not working and it doesn't pass the load test, I will replace those and see what happens. But I'm going to say they're probably good. So, alright, here we go. Let's start with recap. I think we're in decent shape. Like I said, if not, and if this thing doesn't behave properly, I'm just going to replace it. Because I do want to start getting through my stash of amps that I have. Get them out of here. Alright, let's go. Let's start out with C47. C47, 100 UF, 25 volts. We're going to double check all of our caps before we put them in, like always. Because I am human and I make mistakes. It's hard to believe, but I totally do. Solder sucker off. I really wish I could have some background music playing. It'd kind of be nice to have something to listen to. I don't know how you do that though. Like, I know there's non-copyright stuff that you can play, but most of them say you have to put like a link in the description or something. And I don't know how you would link every single one of them that played, so I don't know. I have to look into that. What do you do on a live stream when you want some background noise? I can't be the first person that's wanted to do that, so I'm sure it's been addressed before. Alright. Next cap. It's either, I think it's C38. Do I have it marked as C38 or do I have it marked as C49? C39, C38. Alright, different number. C49, C50, and C38. Do I have a C49? So this is one of those things where like the silk screen is so hard to understand, like you don't really know what you're putting in there. So I have C47, C48. I can clearly see those, but down here there's C38, C49, C50. They're all marked in the same area. C52. I'm going to say I have it marked as C49. 47, 48, 44, 69. C49, there it is. 4.7 bipolar, 50 volts. I believe this is actually C38, but that number was probably covered with glue when I made this list and I couldn't see it. So we're going to go with 49 because that's right there. 4.7, 50 volt bipolar. BP always goes to the negative side. I don't think that's a rule, but that's just how I do it. So I'm going to hand solder all these in, and then what I'm going to do is I'm going to heat up the solder sucker after I trim the leads and make sure that all of these are flowed really well, because a lot of these connect into the ground plane and the hand iron just doesn't get hot enough to solder them, and they're good. So it's kind of another annoyance with these amps, just because they didn't put any thermal brakes on anything. So it is difficult to get the parts in there sometimes. Alright, C48. This should be 125 volts. This is another one that's locked into the ground plane. You can actually kind of be messy when you're putting these in, because we are going to go over them all again. So you don't really have to be pretty when you're just getting them set in. You'll get really good solder joints after you hit them with the higher heat. So just getting them kind of tacked into place and held into place is good enough to start. C56. 56 is 10 UF bipolar. 10 micro bipolar. 10 microfarad 50 volt bipolar. C56. 10, 50 bipolar. C39. 47 at 25 volts. I know we have two of those, so I'm going to grab two. Check our polarity, make sure that's correct. Again, I'm really not being careful putting these in. I'm just kind of tacking them in place just to get them in there, because you have to work on this weird angle and it's just not easy to do. C44. 100 micros, 25 volts. I had one of those. Actually, there's three of those. 4 of those. I need 2 more. 100 at 25. 100 at 25. 1, 2 more of those. These are most likely power supply filters for the op amps. Either that or for the input power coming into the board, the low voltage. Still for the op amps though. Just blob the solder on there. C43. Another 100. Yeah, not a bad design amp, just very difficult to work on. And, I wish they used higher quality caps and didn't use the glue on there. I don't really understand the large resistor in the power supply either, though. That one, I'm not even going to bother with that leg. Alright, we're going to go... I see I did something kind of dumb here by putting this guy in right here. There's one that goes behind it. I should have did that one first. That's, I believe, C54. Yeah. Just 22 at 50. I'll just blame it on being a little bit tired. I haven't been drinking enough coffee, that's what it is. I need more coffee. Gotta drink my coffee. Just down and double check. C54. C54. 22 at 50. We're good. Make sure polarity is correct. Pop them in there. Now when you're working with all these and the legs are sticking out, after you solder them, and I stress after you solder them, you can bend the leads. Not before, after. And the only reason that you can do that is just to get them out of the way so you can work without jabbing one of these into your finger. Alright, we're going to start at the bottom and work up now. C69. C69 is 10 bipolar. C50 bipolar. C69 goes all the way in the back there. This guy, I believe, is part of phase control. Again, I'm just guessing because I have no way to verify any of that, but experience would tell me that's probably what that is. C1. 4.7. There's, I thought I grabbed another one of those. 4.7, 50 bipolar. 4.7, 50 bipolar. Make sure they're straight when you're doing this too. It helps. C42. 42 is 4.750 bipolar. Almost done with the recap. We're like 60%. What's our time? And we're not going to set any records tonight, that's for sure. Alright, we have these two back here, which I believe 29 and 30 are 22s. No, 47s. 47 at 25 volts. Two of those. 47 at 25. The two center legs are grounded, so I'm just going to tack the other sides of them that go to something else other than ground. I'm not even going to bother with the ones that are on the ground plane. You don't get a good connection there anyways. We'll save that for when I got the muscle. Headset's falling off there. Alright, let's see where we're at. Those two are in. I'm gonna do the, I call this one C by R40, just because I don't know what else to call it. I'm gonna do this one before I put that, and that's this guy back here by this little ceramic cap, C by R40. And that's a 2250 volt. Did I grab another one of those? That's a 47. I can put him away. 22 at 50. This one I am going to pre-trim. And the positive goes to the right side. Negative goes this way. I'm going to take some of this nasty lead-free solder off of here. Actually, what I'm going to do is I'm going to fire up the solder sucker. We're almost to solder sucker point anyway, so I'm going to start pumping it up, get it hot. That film cap looks a little loose. Did I yeah, I unsoldered one of his legs, that's why. So we have two more caps that are by where the resistor used to be. We have our failed resistor that we need to and then we have to rebuild. While it's heating up, I guess I can put these other two in. This is C19 and C8. I think that's C80. They're both 2250. These are the two that go right next to where the resistor used to be. Strangely enough, these are not the ones that die. You would think that they would be probably most prone to failure because they're right next to the heat source, but they are not the ones that fail. Generally. We did have this one leak though. That's not a common failure. This is a rarity, something different for a change. And we'll make sure that, you know, we bend them all out of the way and make sure they're, you know, secured nicely where they're not going to get interfered with. And since we're putting the resistor on the bottom, we don't need to bend over that 330 anymore. Our problem child, 330 at 16 volts. Apparently at some point I ordered big ones. I don't remember doing that, but yeah, we're going to put this UPS series in there because these are much better caps. I think I was using the UVZs for a while. I don't know, I might have done one of these on the one of my previous videos. UPS are good caps by Nichicon. I like that series. Again, I'm only tacking one lead in right now. Alright, solder sucker is hot. I'm only going to do one side of this ceramic cap. Actually, I can do both because there's still a considerable amount of solder on there. Alright. Make our leads nice. So they're squared off a little bit. Get a good grip. And we just clip them on the top of the ceramic cap and solder them in. Now I'm going to lean this back a little bit so it's touching the back of the plate. Almost touching the back of the plate, not like relying on it, but I'm going to throw a dab of silicone on there to hold that in place. We want to be able to have that supported. It's a little hard to get back in here, but you have a little patience and you work slow, you'll get a nice solder job, and that guy won't be going anywhere. Put a little bit more on this side. I've seen this amp with and without that mod, so I don't really know what it's used for. Alright, everything looks good. Let's put our transistor back in. I'm going to clean this guy up a little bit. Just give it a little continuity check, make sure it's not shorted. Seems good. Pop this guy back in. I like to lean it back. Just a little bit, not too far. I don't want it touching the resistors that are behind it, but I'm just going to tack one of the legs. Give it a little bit of a lean, and actually I don't need to do that. I keep forgetting. With the resistor on the bottom of the board, you don't need to get that out of the way. So just kidding. You don't have to lean it back. Alright. All of the caps are in, except for the two large ones. We didn't miss any. Now we got to trim. So I'm going to snip all the legs, and then after these are snipped, they're going to get the heat treatment with the higher wattage solder sucker. That way, when you know, we have a connection to one of the ground planes, I know that it's going to get a full solder flow all the way through. And I don't have to worry about weak connections. That is one of the, you know, hard things that you have to, I guess it comes by, you know, learning by doing this type of stuff. You gotta have a few failed connections before you realize that sometimes ground planes can really wreak some havoc on your reworks. They do suck away a lot of heat, you know, and this board is covered with big ground planes. So if you have a puny iron and you're trying to, you know, get a good rework done, you either have to put the iron on the board and just let it bake the board for a while, or you need to invest in something that can put out some more heat and really make sure that you get a good bond. Well, some of these I did not solder in, but it's pretty easy to, what I'm doing, you just put it on there, twist it around a little bit, and lift it off. I'm doing that on all of them. Gravity will force the solder to come down through. And it'll basically wick itself up to the top through hole. Works wonders when you do it this way. Just verify that you're hitting the right components. Make sure that you're not, you know, missing any spots. If you are, hit it with a little bit of solder. You can see the difference when you do it like this. I mean, I can see it, you know, real easily because I have first person view, but you can tell when you hit these grounded leads with the high heat that the solder just gets sucked right in. To me, this extra step is really what takes it from a average repair to an over-the-top, high-quality job. Sure, it takes a little bit more time, but having to rework a job that you did because you got a crappy solder joint, that takes time too, so to me it's worth it just going over these, making sure that all of them are top notch. And it didn't, I don't know, it didn't take that long. So this guy, I'm going to straighten that lead out. That's where the resistors go, but there's a little bent leg there that's annoying me. Alright, so I'm going to give these all a look over, make sure that everything's good, make sure that there's no bad joints. You can just kind of see which ones you've hit and didn't hit, which ones might need a little bit more. So the ones that need to hit the ground plane are really the ones that need to be worried about the most, but I have to re-clear this hole here. Alright, we're going to hit the MOSFET, make sure that that's got plenty. Alright, all we have left is resistor rework and reassembly, and we should be good to go. I'm happy with the way all these solder joints look. They've all wicked through the through holes. There's nice fillets on the top. I'm going to hit this MOSFET again because it is not. This one's giving me some trouble here, so we're going to hit it. My iron won't fit over there. Alright, good solder joints. Onward. Next, we got to do our resistor. I think I am going to put the small surface mount on first because I believe this guy is going to get in the way. I still haven't figured out an ideal mounting situation for this yet. I just kind of wing it bend the leads up so they look nice and throw them in there and solder it. You want it spaced off the board. That's the most important thing. I don't, this is as long as I can make these leads, but something just like that should be fine. You're keeping it away from the caps. You could put it the other way, but your smaller caps are all over on this side of the board. Your large filter caps are on this side. The larger filter caps are going to be able to take a little bit more heat. So I think this is the best spot to put it. That's just my theory. And I need to put the large caps in first because it is covering up the holes there. But that's how I'm going to do it. I'm also going to see, so that resistor came off of this side. And it was on the back part of the board here. Yes. So I'm going to put it right here. Here's what we're going to do. And this is going to be super easy. I am going to take my scraper. And I'm just going to clear this. Clear this solder mask right here, right next to that. Sorry that I keep blowing into the mic, I keep forgetting. Let's zoom in. So this is as close to the original position as you can get it. And you don't have to do it this way. It just makes it easier to do. And then you're not trying to stack anything. So I took the solder mask off the ground plane right here. And if you remember from before, one side of the resistor goes to the front leg of the big guy. So this is the resistor that was in there. And it came up through the bottom. So one side of the little surface mount went to here, and the other side went to the ground plane. And we'll verify that again just by hitting it with the continuity tester. So here's my ground plane. That's the rear pad of that resistor. Now I'm going to go to that little via, which is like going to be impossible to hit, and I am going to touch the through hole to the front of the, well, here, let's see if I can get it to here. Where's my beep? I must have slipped off of it. There, we'll do it like this. I'm going to stick it in that through hole there, and I'll just probe. There it is. So we're going from large pad and ground plane across. And I did say I was going to measure the resistance, so let's go in ohms and see what we get. I don't have the 820 in yet. Alright, so I got 251 ohms before I put that guy in. Let's see what we get after. I'm going to guess it's not going to be a big difference. Maybe it is. I don't know. That was a 1K. I don't believe you need to use 1%, but that's what I have. That's what I'm going to use. $1001 is 1K. It doesn't matter if you use a 603 or an 805. I believe well, what size are the originals? The originals were 805, so you want to use 805 or larger, actually. That does matter. just double check my value on there, make sure I didn't label them wrong. 1001. Looks right. So here's what I'm going to do. I'm going to tin that little pad that I just put down, or cleaned. I made a pad by scraping off the mask. Tin it. Then I'm going to take the tweezers and grab this resistor, and I'm going to put it right over that bridge, because there's a divider there, natural divider, built into the board like an isolation. And I'm just going to solder it right across there. I'm going to do one side at a time. Make sure that it's sitting flat to the board, or as flat as you can get it. This one's like slightly crooked and it's going to annoy me. That's better. And then after I get it flat down to the board, then I'll take my tweezers and straighten it out. My dog is crying. She probably needs to go outside or she wants food, one of the two. Alright. That's as straight as I'm going to be able to get it. So I'm going to make sure that I am splitting that gap, and that no part of that pad is going to cause a short right there. I need to push it back just a little bit. Good thing to check. You want to make sure that you're right in the middle of this device. Since we're not working with like factory created pads, it's a little more difficult. But I think we're good. Alright. Once you're happy with the location, solder it in and be done. A little bit more on there than I wanted to get. Actually, my solder sucker's still hot. You just want like a, you know, a nice little bulb there. You don't want it to get too out of control. But that's also on the ground plane too, so it doesn't hurt to hit it with, you know, a little bit higher heat source. Make sure that it's soldered in nicely. Now we'll check for shorts and check our ohms. Ohms should have went down. Okay, so we're at 201, so not a significant change. Could probably get away without putting it in there. I don't know. We'll leave that one up for debate. Let's finish rebuilding this thing and get it tested. I'm ready to hear this thing work. And then go have some candy bars. Alright, we are 1000 microfarad, 80 volts. It looks like these are my last two. Alright, 1000 at 80 volts. Again, I'm just going to tack these in place just so they don't fall out. And then hit them with the... actually, no, I'm not putting these in yet. I'll tell you why. I want to get these resistors back in, and anything else that's going to be difficult to get to. Not that resistor, though. That's a bad one. This one here. Get some of that nasty glue off. Shouldn't really cause too much of a problem. Orientation. 3 red lines, I believe, goes closest to the cap. Yes, and brown, black, black. What is that, 1 ohm? That one goes back here. I'm not even going to bother. I'm going to hit it with the solder sucker. Make sure that it's bonded well. Home stretch. Inductor. Pop that back in. I'm not going to glue this in. There's no reason to. Just sits on a huge solder pad. It should be more than enough to hold it in place. Alright. Let's make sure all those parts are good. You can be on these areas where they use the solder to increase the current capacity. You can be liberal on any of these areas that are opened up. You know, just blob the solder on there. Get a really good fillet. Especially with leaded solder. That'll really help hold the parts in. Well, we got to do our resistors. Make sure they're bonded in there. This guy here. And this guy here. This one is connected to ground plane, so we want to make sure we get some heat on him. Alright. 2 main caps, main resistor, and we can power this on. This 22's bothering me. Sitting a little bit crooked, that bothered me. Better. Alright, make sure our polarity's good on the big caps. Fire one in there and glob it up. You can leave the legs a little bit longer on the big caps, just so you can get a little more solder in there. These do supply the output rails. To where they are connected to the ground plane, just take your iron and swirl it around the pin. That'll evenly heat up the entire area to make sure you get good flow. Especially if you don't want to change tips, but those are soldered in good. They're not going anywhere. And they'll get some silicone to make sure they're held in place. Alright. I'm going to throw this guy in there. And I do put a little blob of silicone under the resistor too to make sure that it doesn't hit that leg of that cap. Now, since we are flipping this to the bottom of the board, you don't want it sticking through crazy on the top of the board, just kind of like it would if you are soldering, clipping the legs on one of the other components. Make sure it's got a good connection. You can kind of build up the solder a little bit by heating it and letting it cool. Just to give it a little extra. And that's it, we're good. So here's what we got. We have our resistor spaced off the board, spaced away from that cap lead. We'll throw a little bead of silicone under there, just to, you know, protect that for whatever reason if it does bounce, because these are wire wound. We don't want that to short out to the cap. That would be bad. Other than that, we're in pretty good shape. Let's power it on and see if it works. It's that time. I am going to guess that the amp is going to work. Let's shut all this crap off. My irons. Zoom out because the camera's been zoomed in for way too long. Alright, so everything's in. We're going to make sure that our volume is down to 0, our low pass is all the way up, our phase is at 0, and we want the amp on. To 120 volts. I'm not even going to check the fuse because they're never bad. And I need a C16, I think they're called, style plug. We always start out current limited. These amps do cry a little bit because they don't get enough power, but it's alright. We're going to need an input. I'm already set at 40 hertz, so that's good. Let's go to the dummy load. That way we can get a visual. And then after we got a visual, we'll go to the speakers. Now, this, especially into the dummy load, just does not give you a very clean output. But when you put it into the speakers, it's beautiful. So, we're just looking for a sine wave on the output that is going to resemble our 40 hertz. Let's get that light out of the way so we can actually see what's going on, and here we go. Current limit supply on. Let's hope nothing blows up. Light's gonna blink a few times, and we have something down there. It's doing something. Alright, let's which one's gain? Gain is this one here. Let's give it some gain. Oh, I'm seeing some ripples. I'm seeing some sound waves. 38. Oh, we're hitting current limit. Alright, current limit off. We are showing a 44 hertz wave. Looks pretty good to me. And remember, the way that this power supply works, you don't get like a really clean class A-B sine wave. There's like jitter in there. Plus this is a really cheap scope, so that doesn't make it any better. Let's oops, nope. 30 hertz, 40 hertz. 50, 60. It looks good. Good enough to do an audio test on. I am happy with that. Our resistor is getting good and screaming hot, which it's going to do. It's going to stink a little bit when it's breaking in. I'm just going to give the amp a quick little once over, make sure that I didn't miss anything. Making sure that all my caps are in the right direction. I know I did that once already, but it's good to be OCD about that. Alright, let's take this out. This is our dummy load. I really need to come up with a better way for cable management. I am like severely limited on where I can run all my lines. Now these caps are still charged in here, so be careful. Alright, let's see what we get. And I believe that's 160 volts DC. Let's measure that real quick. So you should be real careful around here. From here to where did the Z cap go? There's the from ground. This is no, that's positive. From positive to ground. Ground is on that. Let's see what we got. Right now we have 0. Alright, let's power it on. Amp is powered on, never mind. Let's give it some volume. And let's check our voltage. I don't know what the real voltage is. Is it 80 volts? Is it more than that? I think it's 160 plus minus 80. I could be wrong though. But we're going to carefully measure it. So it's plus minus 60. So 120 volts. Actually, I can just measure it right here. What am I doing? I'm having brain farts tonight. Yeah, it's 120 volts DC. Plus minus 60. So be careful in there. 100 volts DC used to be the safe working limit, so you're 20 volts over that. I think they lowered it to 50 now, but whatever. Still, be careful. 120 volts DC will still give you a nice little buzz. But I have sound. I can hear it. It's not too loud. This amp is back in business. Sounds good. There's no hum. It's got a clean sound wave coming out. Let's see if I can pick that up. I know that's hard to do, but maybe with my enhanced microphone. That's me sticking my finger on the woofer. Here, let's see if I can get it closer so everybody can... I don't know if the mic will pick this up or not. You can see it though. $20 Hz. Sounds good. 30, 40, 50, 60. Alright, so there we have it. Now I'm going to let this amp go through a like a stress test a little bit. I'm going to leave it in probably 20 or 30 hertz, a quarter of the volume, and just let this thing sit and cook. Since there was a lot of glue damage on there, some of the traces were a little corroded, and we also burned off one of the resistors. I want to make sure that this thing is good to go. I don't want to send it back unless I know that it's repaired. I'm going to check and make sure that nothing gets too hot. You know, obviously this resistor is going to get hot. It's designed to get hot, but I want to make sure that it's not getting too hot. So I'll periodically check on that, and that's it. So we have another successful repair on a R-115SW. I know I have at least 4 more of these coming in, so I mean it's going to get real repetitive, but at least this one was a little different. I'm going to update the title just so you know, anybody that is browsing the videos knows that this one had some different issues than just a simple recap. So appreciate anybody tuning in. Remember to like and subscribe, and you know, let me know if there's a specific model you want me to work on, or you know, if you have any questions, I'll try and answer them in the comments as best I can. Appreciate you tuning in for this repair, and I will see you guys all soon. Have a good one.